Hi guys, BuildZoid here, and today we're going to be taking a look at some very strange behavior with the 12900K that I've stumbled across. So basically, if you have a 12th gen CPU and you put a relatively well, let's first run it on completely auto. I'm just going to put the CPU back to auto, and we're going to run Cinebench, and everything will be good. And then we're going to try just like a negative voltage offset. We're going to fiddle with the load line calibration settings a bit. Actually, I forgot to set that to auto, so we need to do that. We're just going to set that to auto as well. The G plus VRM. Let's put that on auto. Now we're going to run some Cinebench, just to get like a baseline score here. So yeah, we're just going to run Cinebench, and also actually we'll pull up hardware info so that we can look at the core clocks, because basically what we're going to do is we're going to make Cinebench run very, very slowly while all of the software is still reporting the same clock speed, which is just like, I love modern hardware. Anyway, so now Cinebench is running, and hardware info is reporting effective clocks of 4.9 gigahertz on all of the cores. Cinebench is running at a reasonable speed for Cinebench. Temperatures are rather high because Intel's stock voltage curve is very aggressive. Like 4.9 gigahertz does not need... Yeah, 1.33 volts, oh man. That is enough voltage to do over 5 gigahertz on most CPUs. Especially in Cinebench, that is more than enough voltage to go over 5 gigahertz. But anyway, so Intel has this extremely aggressive stock voltage because the idea behind this is that it gives you headroom for terribly designed motherboards. Anyway, so yeah, so that gets 7,672 points, and that's with me also like messing around in hardware info. Really, we should be getting like 7,700, maybe slightly more than that at 4.9 gigahertz. And yeah, we're just going to slightly reduce the voltage, and you know, it's not going to crash. It's going to run super slowly. So we're just going to stop this, and we're going to restart. And the first thing we'll do is just set like a minus, I don't know, 100 millivolt offset. Because the reason I stumbled across this was I was trying to run Linpack, right? For memory stress testing. And of course, Linpack at 1.3 volts is not okay. That is very not okay with a 240mm AIO. So I decided, you know what? I'm going to make some adjustments so that the CPU doesn't like try to set itself on fire when running Linpack. And instead, Linpack ended up running extremely slowly. Actually, you know what? We're going to start with 50 millivolts, because the effect shows up pretty early, and I don't know what'll happen at minus 100, but yeah, we're going to try minus 50. And in theory, I shouldn't even really have to pull up hardware info just yet. We should be able to tell that there's a problem just from the score. Seems to be running just fine right now. Yeah, this doesn't seem any slower. I wonder why that is. Yeah, it's not any slower yet. Okay. Let's try more then. Oh, actually, before we try that... Oh, too late. I want to check the voltage. Is it actually lower? Okay, it is lower. Cool. I guess it maybe the effect, like the thing is, I noticed the effect in Linpack, so maybe the effect doesn't occur at the same voltage for all workloads, but let's keep going. See what happens. Interesting. So it just crashed, so the voltage is too low now. That is very odd. So the reason that happens is that the Windows boot up actually loads up all of the CPU cores for a little bit. So we should be able to get into the BIOS and change the voltage. 7. Okay, so that's too much of a negative offset. So what we're gonna try now is we're just gonna go to level 1 on LLC. Actually, I should have put the core voltage back to... Did I put it back to auto? I don't think... Well, I'll check. Oh, yeah, I didn't put it back on auto. There, let's put it all the way back to auto. Okay. Okay, so Windows now starts just fine. And with any luck, Cinebench will run at snail speeds. I don't think it's doing it. What the hell? What voltage are we at? 1.243. Okay. It's a good voltage to be at. It's coolable. Oh, no, it did slow down. It just didn't slow down enough. Man, I was so worried I was not going to be able to replicate the effect on video. But yeah, no, here you have it, right? And if you scroll around in hardware info, right, effective clock for, I mean, let's just reset the, yeah, it's 4.9. Effective clock is 4.9 gigahertz. Everything is reporting 4.9 gigahertz, but it is very clearly not performing the way it should be, right? Like, it's supposed to be spitting out 7,000 points. It's spitting out 2,000 points less than it's supposed to be. And the funny thing is, you can make it even worse. Like, I can get the CPU to run at like half its real speed. Like, even if I leave hardware, like if I close hardware info so that it's not, using up resources in the background of Cinebench, like it's not going to go back up to 7,000. Okay, so the effect is real and I'm not crazy. It's weird. It's hard to trigger though, and it seems to only happen when you change the LLC settings, which is very interesting. Like that is very, very interesting because I don't know how the CPU is able to like, because it's clock stretching. Like what's going on is like everything, like if I pull up CPU-Z, and I'll do it after this run finishes. Like if I pull up CPU-Z, you'll see that it's reporting 4.9 gigahertz on all cores, and this is, yeah, like it's running like, it's sped up a little bit, but it's still way too slow. Like this is supposed to be producing 7,700 points ish. But yeah, even CPU-Z, 4.9, right? Everything is reporting 4.9 gigahertz, but the CPU is very clearly not doing 4.9 gigahertz worth of work. It's doing like 4 gigahertz worth of work. Actually, yeah, it's doing like 4 gigahertz worth of work. So it's clock stretching really hard. Um, and so the thing is, you can make it even worse. But yeah, it's a weird, like, it's a hard to trigger effect, and I don't know how the CPU is able to distinguish between, like, the offset being too low and, like, because when I set the offset to minus 100, right, it just crashed, which is what you'd expect it to, like, which is what I would expect with the LLC like this, right? Because the LLC is reducing how much voltage we're getting under load, and so I figured, hey, like, it should be an effective way of reducing the CPU's power consumption and heat output. But instead it just makes the CPU slow down. I mean, that does also reduce the heat output, but I don't want it to underperform. So we're going to try 50 millivolts offset on top of that. And now we should be running at like 3 gigahertz under load, even though the CPU is still reporting 4.9 in absolutely every piece of software that I'm aware of, at least. And yeah, like this is just super wacky. That like you can do this. So now I wonder if like leaving LLC on auto and maybe like a minus, because the whole reason I ran into this was just like trying to get Linpack to stop thermal throttling. Yeah, so now we're gonna run Cinebench at like snail speeds. Oh, come on, it's grabbing the wrong window. There we go. I'm just gonna wait for that to start. Oh man, it's gonna take forever. Yeah, you can see it. It is running. But look, like hardware info is reporting 4.9 gigahertz effective clock on everything. But Cinebench is running at snail speeds. It's going to take forever. It's still not that bad. It's kind of crazy how powerful the 12900K is. But at this point, it should be approaching like 3 gigahertz real clock or like performance clock. Or what hardware info would call effective clock if it could actually measure it, apparently. I would love to know how hardware info actually does the effective clock thing. Yeah, anyway, at this point, like, when I first ran into this effect, I managed to get Cinebench to produce 3,000 points. So I'm hoping to get that right now. That's what I'm aiming for here. Looks like we might get that. I have a really terrible sense of time, so this to me feels roughly the same as before, so I can't tell. And yeah, 3,321 points. I have, like, all of the software says the CPU is at 4.9 gigahertz. If I pull up Task Manager, Task Manager is being a... Oh no, what did I do? Yeah, Task Manager believes the CPU is running at 4.9 gigahertz. What else could I pull up? CPU Z, right? Like, the CPU is literally producing less than half the score that it's supposed to be producing. It's probably running actually less than 3 gigahertz at this point. Because at 4.9 it gets 7,700 points. We're at 3,300 points. So that's less than half of the score that we get at 4.9. It's got to be running at like 2.5 gigahertz or something. Like, it is clock stretching. Like, this is basically, actually, no, I mean, I've managed to get something similar on a GTX 1070 when I ran it at 0.7 volts, but at like full 3D. Yeah, it was 0.7, something like that. Like, it was a really, really low voltage, and the card would report that it's running at like 2.1, 2.2 gigahertz, but it was rendering like 10 frames per second in benchmarks where it would normally produce like 60. So it was actually running at like 1/60th the usual clock speed, which was great. Anyway, so this is running at like half speed, less than half speed, right? Task Manager thinks we're at 4.9. CPU-Z thinks we're at 4.9. What does IDA think? IDA probably thinks we're at 4.9 as well. Assuming that I can get IDA to open while Cinebench is running at this speed. So yeah, this is a really wacky thing. I think it thinks we're at 4.9. I'm not sure. I've not really ever used IDA for any validation, so yeah. Anyway, let's close all of that. And now I want to try something. I want to try if I can get Linpack to not set itself on fire. So we're going to turn off the LLC. We're going to put that back to auto, and I'm going to put in like a minus 70 millivolt offset, and we'll see what happens. Because, like, the effect... Wait. Yeah, the effect wasn't really kicking in on auto LLC. So, yeah, evidently it's some weird thing, like weird interaction with the LLC on the CPU. I still don't get how the CPU, like, figures that out, though. That it's like, oh, there's, like... How does it know when to clock stretch and when not to clock stretch? Because imagine if you could trigger this on purpose. It would be so convenient. You'd never blue screen. Right? Because, like, how does it do that? Well, I guess it actually probably has plenty of voltage for 4.9 gigahertz. I don't know. I really, like, this is one of those things, like, yeah, clock stretching is weird. Also, the annoying thing is, like, there's no practical purpose for it. Like, there's no practical use for it. Like, you can't intentionally use it to avoid blue screens or something. If you could, that would be so cool. But instead, it just kind of gets in the way of actually being able to do anything. And we're first going to hit this with Cinebench, because I want to make sure that, like, performance is where it's supposed to be. Because, like, Linpack, if Linpack isn't running at full speed, it's going to take forever, and I don't really feel like waiting for that. I get the feeling Cinebench is not running properly. It looks a bit slow, doesn't it? .26. That is like there should be plenty of voltage. Like, obviously, like, if the CPU has determined that actually, no, this isn't enough voltage, then whatever I think is irrelevant, but... Oh no, it is clock stretching again. Not as much as before, but it is definitely clock stretching. Okay, that is... So actually, we can't run Linpack like this. That's really dumb. That is really, really dumb. Yeah, so basically, because here's the problem. Okay, I'm gonna restart and we're gonna hit Linpack with no voltage offsets, no nothing. Now, admittedly, I do have the multi-core enhancement enabled on this board, so the power limit is just gone. But the thing is, if I have a power limit, Linpack is just going to run slower because instead of clock stretching, it'll just underclock itself. Like, instead of thermal throttling, it'll just power throttle. And it's like, we're back to square one. It's not running as fast as I want it to run. And this is not like, don't get me wrong, I'm not criticizing the motherboard for this. It is just a very strange Intel CPU behavior. That we're looking at here. Like, yeah, okay, so we're going to set that back to auto. Actually, we're going to just set it, just in case. Auto. Everything's auto, right? And now we're going to try to run Linpack, and it is going to run way too hot because the CPU and its stock voltage table is completely insane. Admittedly, my 12900K is, like, really bad. But even that... Where's Linpack? There's Linpack. Actually, let's first check Cinebench, like Cinebench is running properly. Because that's the thing, is like when you have this clock stretching behavior, the problem is like, yeah, you can go into your software and you can look at whatever frequency the CPU wants you to think it's running at. It doesn't matter. You have to run a benchmark. Because if you don't run a benchmark, is it actually running at that frequency? Just because the CPU says it's at 5 gigahertz doesn't actually mean anything. So, or 4.9 in this case. I do kind of wonder what the auto voltage is right now. It should be 1.32 like it was. Yeah, it is 1.32. Okay, so me having some voltage punched into the manual mode isn't affecting the results because, yeah. Cool. So we should get 7,000 points, 700-ish. Yep. So it is actually running at 4.9 gigahertz right now. And now the problem is, well, okay, so that's great. So Cinebench is performing properly, but Cinebench is running at like 80 degrees. So guess what happens when we run Linpack? And also, we can't run hardware info at the same time as Linpack on... Well, you can, but on a lot of Asus boards, you'll lose a bunch of performance in Linpack because there's some sensors that get pulled way too much, and it chews up a bunch of performance. So I use core temp when running Linpack so that we can see the CPU temperatures. Because this puts a lot less, like, this gets in the way of Linpack less. So anyway, 5... And we're just going to hit 3 loops, and yes, yes, no. I mean, we're probably only going to run 1 loop, and it's just going to go to 100 degrees in a couple seconds, and that's going to be the end of that. Actually, we could probably pull up CPU-Z so that we can see what happens to the clocks when that occurs. So yeah, immediately... Oh, it's not thermal throttling. Why is it... Oh, I'll give it a... Oh, I guess the room's a bit cooler. Oh, there we go. One of the cores hit 100 already. And another one. Not seeing the clocks drop yet. Still at 4... Oh, wait. I turned off the thermal throttle, I think. Right. Yeah, I did come up with that workaround. Yeah, so there is a little trick you can use to force Linpack to run at full speed, but it's a really bad idea. So I forgot that I did this. Because, like, ultimately, I just gave, like, once I realized, like, hey, any adjustment to the voltage is just going to make Linpack, like, any major adjustment to the voltage is going to make Linpack just not run at full speed. I came up with the ingenious idea of just going CPU configuration, and you have this right here. Where is it? No, it's in CPU with power management. Thermal monitor, yes, this. If you disable that, the CPU stops throttling. But yeah, like you shouldn't do that. Um, Basically, that disables the CPU's like thermal limiting capabilities, which is a bad idea for the health of the CPU. So, yeah. Now it should thermal throttle in Linpack. Like this setting didn't affect any of the Cinebench results because in Cinebench we weren't hitting the thermal limit. 253, yes, yes. And I also need to get CPU Z up. It's not good to be, opening stuff while the stress test is running. No, enter. There we go. Okay, it's running. Sure, it's taking its time to hit 100C right now. Oh, there we go. Still not dropping clocks, though. How? Oh, there we go. Yeah, okay. Now it's finally starting to drop the clocks. Yeah, so some of the cores are hitting 4.8. Yeah, so basically I ran into this because, I use Linpack for memory stress testing because it hammers the memory controller. Except you can't run, like if it's thermal throttling like this, that's not okay. I mean, it's not dragging down the score too much. 593 gigaflops isn't that far off of what it's supposed to be, which is 600-ish, but actually it's supposed to be over 600 at 4.9 gigahertz, but yeah, I mean, we are on an AIO, so if I let it run for long enough, it'll eventually the water temperature will go up and it'll thermal throttle more and more and more. But yeah, so that's it. That's all I wanted to show. So that's kind of this is really annoying for me. Like it's not a big deal, right? Like if you don't have a 12900K, this actually isn't a problem because the other CPUs aren't insane. Or at least I would assume well, okay, no. If you have anything other than an 8 core, this isn't a problem. The 8 cores they run very hot. The 6 core CPUs and lower, they don't run this ridiculously hot. Because they have less cores, but yeah, this is just really frustrating because it's like, oh, I want to run Linpack, and then it's like, but Linpack isn't running at full speed because this like, and there's no way for me to reduce the operating temperature of the CPU because it's like if you start fiddling with the voltage instead of thermal throttling, it starts it just starts clock stretching, and the clock stretching is worse at minus 50 millivolts. Linpack drops to like 530 gigaflops. So in Cinebench, the clock stretching, wasn't very significant. In Linpack, it's way worse, and I'm assuming it's just because Linpack is way harder on the CPU, so the CPU clock stretches even more than it does in Cinebench. So yeah, that is super annoying. Just like modern hardware, man. It just sucks. Like first GPUs started to do this. Actually, no, I think AMD first introduced this with Bulldozer CPUs, but the first time I ever really ran into this and got annoyed about it was 10 series NVIDIA GPUs. Actually, there's even 700 series and 900 series actually have clock stretching functionality built into them, but 10 series is the first time I really noticed it. And then, Ryzen does it, and it's annoying on Ryzen, and now Intel does it, and it's also annoying. Admittedly, I've never actually done like negative voltage offsets on Intel CPUs in the past. There's just never been a need for me to do that, right? Because I've never been on a yeah, I don't generally mess with locked Intel boards, right? Like I've not messed with a B660 style motherboard. And so I didn't realize that like if you lower the voltage of the CPU just does this. So I don't know if like 11th gen did this. It might. Um, but yeah, 12th gen has some very impressive clock stretching capabilities that don't get picked up by hardware info. Like that's the part that frustrates me the most because it's like we literally ran Cinebench at less than half the speed that it was supposed to run at, and the entire time the CPU was reporting 4.9 gigahertz, both for like effective clock and like reported clock. Like, why doesn't it just blue screen? Like that would be the appropriate behavior in my opinion. The CPU doesn't get enough voltage, you get a blue screen. Not randomly diminished performance based on what workload you're running. Like that's infuriating as far as I'm concerned because it makes it incredibly difficult to figure out if there is or isn't like if it is or isn't clock stretching because it's like, oh, if you run this, then it clock stretches a little, but if you run this, it clock stretches a lot. But yeah, anyway, that's it for this video. Um, Hopefully it's somewhat helpful. Probably like I don't know. Like I just find this behavior interesting. I thought you should know about it. So this probably isn't helpful in any way, shape, or form to anybody. But yeah, this is a thing on Intel CPUs now, or maybe it was a thing earlier. I just never noticed. But yeah, on 12th gen, there is crazy amounts of clock stretching if you do. If you try to undervolt too much, you won't necessarily crash. You'll just like lose a bunch of performance without having any indication that it's losing performance unless you actually benchmark it. Like that's the really annoying thing. And also one of the reasons why I just do not care what frequency modern CPUs report, because as far as I'm concerned, like they're lying. Like straight up, it's one of the reasons why like PBO annoys me to no end is like, yes, I can see that PBO reports higher CPU clocks. I am not seeing higher performance though, therefore the clocks are fake. So, yeah. And now we've got 12th gen. Now, luckily, 12th gen CPUs don't have some silly PBO style overclocking system. So you don't have to, you don't have to worry about like, oh, is the CPU actually performing faster or is it just saying it's running faster? But evidently with undervolting, you can make the CPU report that it isn't underclocking itself when it is, which is annoying to say the least. Anyway, that's it for the video. So thanks for watching. Like, share, subscribe, leave any comments, questions, suggestions down in the comment section below. If you'd like to support what I do here with actually hardcore overclocking, I have a Patreon. There's a link to that down in the description below. There's also the AHOC Teespring store where you can pick up shirts, hoodies, posters, the usual YouTuber merch. And I also have a Bandcamp. If you hate your ears, you might want to check that out. But yeah. Anyway, that's it for the video. Thanks for watching and goodbye.